Hello, everybody. There's some questions and always some confusions using StatCrunch with Chapter 3 work, the numerical measures, as we start actually doing some calculations with data. So I wanted to make a quick video kind of walking through some of those key calculations and what to I find and how to use StatCrunch for these calculations. Okay, so I'm going to start to share my screen for for the Canvas page and StatCrunch so we can start to do that. So let's see here. Okay, sorry about that. Sharing. Boom. Yeah, there we go. All right, so we should now see my Canvas page here. This is our Canvas course page. Items around, sorry about that. And so again, our Canvas homepage, some of the announcements and upcoming things to do, homework assignments, quizzes will show up here that are on my lab, as well as our check-ins and review sets. So real quick, an introduction to our homepage as well, right? Syllabus information in case you have any questions, contact information. There's my Zoom office hours, in-person office hours, same time. All that information that was provided on our homepage for the syllabus, in-person exams, final exam information, the grading, important dates, so on our syllabus. Announcements here. We see the announcements that have started throughout the semester, right? Our upcoming in-person exam details here. I'm going to jump to the side here for our modules. Here I have written notes, PDF files, some notes that I had for my in-person teaching classes in previous semesters to go along with each chapter. So in case that's supportive for you, like on top of reading the book, you can look at some of these notes that I had done in class, has some of those calculations, some formulas, and some discussion there to hopefully clarify some information about that standard deviation, which I know is kind of a new topic and difficult topic to cover in that first time learning statistics, but definitely something we use a lot moving forward. And then going through, right, remaining information for our course. There's also a link for the assignments. I know it's kind of organized oddly. You can do it showing by date or you can show by type, but date kind of showing what's due, what's more kind of current. Then you can always scroll down, partner scrolling quickly. Some of those past assignments. And again, with these past assignments, the online homework's included, right? You can go back to those at any time in the semester, rework those, get a higher score. So just in case maybe you didn't score as well, there's no penalty for turning them late. So again, even if you are falling a little bit behind, make sure you do that work because the homework does count towards your overall course grade. There is a discussions section just in case you want to ask questions. Not very many students use these in my previous semesters, but in case you do want to like start a topic and ask questions about particular chapters, right? Kind of help things get focused. You can ask questions here. I can respond, or your classmates can respond as well. All right. You can always double check your grades, your current standing. The online homework assignments, they don't necessarily show up as zeros missing. So definitely make sure you kind of keep track of how many points you've earned because that total point accumulation is how I grade at the end of the semester. But more importantly, what I wanted to cover for our discussion, right, is that work with the Pearson homework in chapter 3 and the StatCrunch there. So, right, so with Pearson, you can open Pearson and then it'll look like this, and you open my lab. Again, yours might look a little bit different. I have the instructor view going, but with our assignments, okay, on this is my lab view of it. I have a little bit of instructor view, but with the assignments from our Pearson My Lab and Mastering, right? You might see some of the assignments due, okay? And again, I'll go over here to assignments. And as we start to calculate, let me jump to section 3.2, those measures of dispersion, the standard deviation and variance information, okay? Maybe I want to improve my score. As I mentioned, you can kind of go through anytime and improve your score. You can review and practice. Review, it doesn't change the score, but if you will improve, definitely, you can increase. So in case you don't have that 100%, you can do so, Right, I was working on a problem with a student previously. So if I start a different problem, let me look at number 6, let's say, as it starts to open up. Let me switch my sharing since I want to make sure you can see everything on my screen there. Or everything on this part. So let me go screen 2. All right, so I'm going to share this screen. Pardon me if I'm not looking directly at y'all during this time, but there we go. So here's our MyLab homework, which you should see. And in this case, this problem, I kind of asking, identifying which of these graphs. But let me jump to a problem where there's some StatCrunch calculations. Okay, and let's see how this goes. So choose the correct answer. So for each of the following data sets, decide which has a higher standard deviation, if any, without doing any computation. So I want to do a calculation, so my apologies. Let's jump to a calculation one. We can go back to that. All right, so here we go. So the accompanying data represents the weights in grams of a random sample. So keep track, this is a sample of 48 M&M candies, complete parts A through F. All right, so let's go through. So let's look at this data. So here's our M&M candy weights, all this data. So in the upper right corner here, we can copy or open this data in Excel, copy to a clipboard if you want to put in a different program, but we're going to do StatCrunch, right? Our course is built on StatCrunch, so we can do StatCrunch. Now it's opening that for me. With me. All right, so here's all of our data. So if you want to, right here, right, you can name the data, like this is M&Ms, okay? Or you can leave it as that var, the variable 2, so on. Notice all of our data is in a column here. And so if I want to calculate the standard deviation, right? So our first question, I'm moving that away, determine the sample standard deviation. So in this case, for a sample standard deviation, in our StatCrunch, right, we're going to go to stat, summary stats, and notice our data is in columns, so we're going to do columns. Clicking here. Where's our data? It's in the M&M candy. If we had left it that generic var 1, var 2, we could identify which column we're working on. I don't need to worry about where, or we're not going to do any grouping. But now down below, what statistics you want to calculate, right? And so you can calculate everything, or we can be specific. We can calculate the mean, variance, which is a standard deviation squared, standard deviation. So one thing I want to know, this is an important fact for StatCrunch, we have to keep track of whether we have our data as a sample or a population. So for sample data, we just use the standard deviation. We can look for another problem in the future if it's a population, that's sigma. For a population standard deviation, if you scroll down here, notice there's unadjusted variance, unadjusted standard deviation. I know it's kind of hidden. I think it's probably because it's in alphabetical order, or maybe not with that standard deviation. But if we do this unadjusted, I'm going to do this one as well. Okay. So the standard deviations, this is our sample. Unadjusted standard deviation, that's for the entire population. And it's kind of, I relate it to the formula in the standard deviation formula for the population. The denominator, right, that's square root. Inside the square root, the denominator is just n, the population size. With a sample standard deviation, that denominator becomes n minus 1. They do an adjustment because it's just a sample. It's a small group of the entire population. So with that work, I'm not going to worry about percentiles. We can come back to our work in section 3.4 for that. But now computing down here, now we're going to see our information. So what data we're talking about, the M&M candies. So this is my sample standard deviation, and this is the long unrounded decimal value. So when it comes to our problems on the exam, on work we do by hand, I'm going to ask for that full unrounded value, and I mean copying this so I can kind of double check our data in case later if we're typing in data on our own, I can kind of double check to see maybe we missed a decimal point somewhere or mistyped. I can verify. This one over here, right, this is my unadjusted, that's my population standard deviation. There's not much difference between the two in this particular case, probably because we do have a bigger data set, the values might be pretty close. But definitely if we have a smaller sample, comparing population calculation versus sample, there might be a bigger discrepancy, a bigger difference. So it's important to keep track whether we have the population or the sample standard deviation, okay? And so in this case, since this was talking about a random sample, now when I want to calculate my sample standard deviation, we're going to round to 3 decimal places. So in this case, I'm rounding to 1, 2, 3 decimal places. Looking to the right, that 9 is going to round that 5 up. So in this case, as a decimal, typing in 0.036. Let's check that answer. Great. Okay. So now this next part, so on the basis of the accompanying histogram, comment on the appropriateness of using the empirical rule. So the empirical rule is for a normal distribution, right? That bell-shaped curve. Okay. We're going to see that a lot more in chapter 7, the normal distribution, where we kind of have that peak in the middle, and then on the outside edges, it kind of tapers down, it drops at a symmetrical type of shape. So if I open up this graph here, try to make this a little bit bigger, notice in this data, we do have that peak in the middle, but not necessarily similar heights on either side. So I would say it's kind of skewed to the left, right? We have our high peaks on the right side, it's stretched out, lower frequencies, lower high bars on the left side. And so in this case, let's see what happens if I say is not approximately bell-shaped, so we cannot use, right? The only time we can use the empirical rule is if it's indeed approximately normal. So let's say here, in my opinion, it doesn't really look normal. Let's see what they say. No, okay, so let's say maybe it is approximately bell-shaped, so we can use it. This says note here the wording cannot be used. If it is approximately bell-shaped, there we go. So it says it's normal, but again, with some of these smaller data sets, it's harder to tell. And now, in this case, using the empirical rule, determine the percentage of M&Ms with weights between 0.804 and 0.984. Hint, X bar, the mean is 0.876. Okay, so now the empirical rule is talking about like how far or how much data, what percent of data is within 1 standard deviation above and below, 2 standard deviations above and below. So in this problem, let me sneak to a calculator. Oh, sorry, that part back here real quick. But over here, if I do a scientific calculator, remember it says, okay, that the mean is 0.876. Let me just put that as a placeholder. Our standard deviation we found, right? That sample standard deviation S we're going to use was, we calculated 0.036. We rounded 3 decimal places. And so now if I want to start to see kind of this interval, this space, what's 1 standard deviation above, we go 0.876 plus 1 of our standard deviations, 0.36. So 1 standard deviation above is 0.912. If I do 1 standard deviation below, 0.876. 1 below the mean, minus 0.036, 0.84. If I want to do 2 standard deviations above or below, right, we do the same, 0.876 plus 2 times 0.036. Make sure I get my decimal there. So now there's 2 decimal places or 2 standard deviations above. If I do 2 standard deviations below, minus 2 times that 0.036, 0.084. So now that, notice these values here, shrink this a little bit. We want to see what's between 0.084, which was 2 standard deviations below, 0.948, which was 2 standard deviations above. So in that space, in that interval, the amount of data that's between 2 standard deviations, with our empirical rule, I believe it was 95%, right? As an integer or decimal, don't round. So I'm pretty sure it was at 95%. Let's check if I remember correctly. Good. Okay. 1 standard deviation was, I believe, 68%. 3 standard deviations, right? Because now we got a bigger space. We're incorporating more data. I think that's like 99 or 97%, like that. Okay. And again, you can double check the book or the notes for those. So now determine the actual percentage between those weights inclusive, right? So in that case, if I want to find the actual percentage of those data of the points between 0.084 and 0.948 grams, right? What we need to do is we need to actually look at our data. So in our data set, let me close this for a moment. In this column, I need to rearrange. I want to figure out what's between 0.084 or 0.804 and 0.948. So I need to arrange this data in order. So if we want to rearrange, we could go to this little arrow pointing down on that column of that data, and we want to sort that table descending, or ascending, climbing from least to greatest. Descending means starts big, goes to small. Ascending starts small, goes to big. So if I do sort table ascending, there we go. So now it's from least to greatest. And now if I want to be between 0.804, right? So that's going to start off with that 0.81. That's definitely bigger than that 0.804. And we want to go as much as 0.948 going down here. 948. So in this case, since these data values are just 2 decimal places, this 0.95 is there. 0.94, this is too big. So basically, the only ones that are not between are the 0.95 and that 0.79. So there's 2 data values, right? 2 out of the 48 that are not, right? Remember, there's 48 values. Just go down here, 48 data values. So 2 out of the 48 are not in that range. So that means 46 out of 48 are, okay? They're within that space, okay? And so if I want to calculate, okay, well, 46 out of 48, there's my long decimal, right? So again, in some of the calculations, I ask for an unrounded decimal. There's what we're looking for, okay? And then we want to round. So it says over here, round to 1 decimal place, and this is a percent. So there's my decimal. To convert to a percent, we move the decimal place over 1 twice. We're going to keep 1 decimal. So now that 8 is going to be after our decimal point. The 3 says that 8 can stay the same. So I'm going to say 95.8. Let's check. Great. Okay. Last question. Use that empirical rule to determine the percentage that weigh more than 0.912 grams. Okay. And so in this case, if I do that 0.876 and I start to add 3 standard deviations, let's see how far that is. Our standard deviation over 0.036. Oh, 0.9112. Where was 912? So 912 was, there we go. So that was 1 standard deviation, right? So we want to be more than 0.912 grams, okay? And so with that work, remember it was 68% that are between, okay? So that means that 32% on either side are either above or below that 1 standard deviation. If I want to be bigger, so I'm on that right side, if there's 32% total, half of it's going to be 16%. Let's see if I got that right. 16%, check. There we go, right? So there's that part. Okay. And then the actual percentage, I'm going to leave this one off. That's more of that calculation, similar to what we did with our data set before, right? Counting how many values are bigger than that 9.912, right? Divided by 48. I'm going to leave that to you all to kind of think about and look at, okay? All right, so with that said, now let's try a different problem. Okay, calculating here, let's go to number 10. Actually, let me make sure I save my work. Okay. Oh, that was number 10. Oops, sorry. Now I'm back here. So let's go back to another assignment. Let's try here. Let's go to this measures of central tendency, the mean, and dispersion for group data. Okay. So I want to improve my score. We'll do this one again. Okay. So let's say we're going to do this problem number 3. Here we go. Looking for group data now. So now this is a good problem because now it's asking for these midpoints, right? So here we can open the frequency distribution, or these frequency distributions are using unequal class width. Okay, well, it'll be small and large. Consider the following data. Determine the class midpoint, okay, for each class and approximate the mean and standard deviation temperature. Okay. All right, so let's see here. What do they have? So they gave us our frequencies there. We'll open that in StatCrunch, or we can do that right here. Open in StatCrunch, okay? Just so we have it. All right, so there's our lower limits, upper limits. There's our frequencies, okay? That's now an important aspect of for our particular author. Different textbooks, different authors, different statisticians, mathematicians calculate this differently, so it is kind of a little bit odd. But for our class, the class midpoint, we're going to calculate that by doing our midpoint of our consecutive, put it this way, of consecutive, see if it shows up, consecutive lower limits. This show? No. Okay. And so in this case, it's going to be that midpoint of the consecutive lower limits. So I want to find the halfway point between those pairs, right? So in this case, let me bring in my scientific calculator. Okay. If I want to find that first class midpoint, okay, I'll just start typing them here. Okay. Going back down here, let me get rid of our old information. I know, exciting for this video, but here we go. Right, so now here's our lower limits, right? So if I want to find the first class midpoint, I want to find the midpoint between these two lower limits. So we're going to make a fraction. We're going to go over the division, 61 plus 65. So make sure you do that addition first. Then we're going to divide that by 2. So our first class midpoint, 63. The next pair, 65 plus 68. And now here, when it comes to your calculations, right, be careful, because if I just say, okay, I'm going to do 65 plus 68 divided by 2, notice it only puts that 68 as part of my division. So on your scientific calculator, or even with this Desmos, we can use parentheses to keep track. I'm going to add first, then we're going to divide by 2, right? So now it keeps track that we have to do that addition first. So my next class midpoint, 66.5. Continuing that pattern, let me make my fraction first. 68 plus 70 divided by 2, 69. Next class midpoint, 70 plus 71 divided by 2. That one might be able to do in our head, right? 70.5. And again, it's not very often that we see these classes that have different class widths, that we have such peculiar ways of separating. Usually it's very uniform in our class widths. And again, the class widths, we find the difference between consecutive lower limits, 65 minus 61, 68 minus 65, so on, to get the class width. All right. And so then this last one, 70, or this next one, 73 plus 77 divided by 2, 75. Okay. And let's see here, going back to our problem. I know I'm going to need a midpoint in this case, right? So in this problem, notice our upper limit was 80.99. So in this case, if I had another class, its lower limit would be 81. So if I want to find this next midpoint, I would have to take 77 plus where the next class would begin, 81, and divide that by 2. So then my last midpoint, 79, right? So for every class, 1, 2, 3, 4, 5, 6, 7. I should have 7 midpoints. Our midpoint for each class, 1, 2, 3, 4, 5, 6, 7. And then this lower, right? Even though I don't have another class, since that's part of my formula, we can identify, okay, if this one stops at 80.99, my next lower limit would have been 81 if I had a class there, and using that to build up his midpoints. Okay, so with that said, coming back to the homework set for our class midpoint, 63, 66.5, 69, 70.5, 72, 75, and 79. Okay. An answer? Wonderful. Thank goodness. All right. So the next part, the sample means. Now, this part kind of interesting. Now we want to calculate a sample mean. I'm gonna clear out some of these values I put in here just so it doesn't get in the way of our calculations later. All right, but now for the sample mean, or likewise when it comes into a standard deviation for group data, since we don't have those specific, right? There's 30 values of our data that's between 61 to 64 degrees, but I don't know what they are. Are a lot of them closer to 61? Are a lot of them close to 64? I don't know the exact value. So I can't calculate a precise mean. So we need to do some work in that kind of estimation of what that sample mean or standard deviation will be. And so in that case, we're going to use these midpoints as a representative. So now when I want to calculate the mean standard deviation, again, we're doing summary stats, but now we have grouped or bin, right? We put everything in a bin, a little bucket of these different groups, these classes. So I go to grouped bin data, our bins, right? Our different groupings. So looking at our data, our information, coming back to our StatCrunch, let me close this for a second. Our actual bins, our groups, our classes are in the temperature. I'm not going to use that lower limit, upper limit. That was helping us in our calculation. But we notice my temperatures, that's our classes. All right. And then here's our frequencies. So now I go to stat, summary stats, grouped or bin data. Our bins are in the temperatures, the counts, right? How many values are there? We're counting the frequency. That's a frequency. Now, this is an important aspect, again, for our particular author, our class. Midpoints are defined using average of consecutive lower limit. Okay. Other books just use limits, the upper or the lower and upper limit. But our book, our author, uses consecutive lower limits. So now if I want to calculate the mean, and again, whether it's population or sample, the mean is the same calculation. And then I'm going to do a sample standard deviation because I'm going to assume we have a sample of data here. It's not all the possible temperatures, right? But let's see what it says here. Okay, so standard deviation, we're going to compute. And so there, for that column of our temperatures, our mean, 70.77607, standard deviation, which I'm assuming they're going to ask for next. Let's see. All right, so in this case, for our mean, there's my unrounded decimal value. We want to round to one decimal place. So that 7 outside is going to round that last 7 in the tens place up. So we get 70.8. Let's check. Good. Standard deviation. So let's just take a second. What if we did instead? Let's see if it makes any difference. I'm going to do the group bin data. Our bins were the temperatures. Our counts were in the frequencies, right? Let's see if I forget to change it to consecutive lower limits. Let's look at the sample standard deviation. At the same time, I'm going to look at the unadjusted population. Let's see if they're any different, right? Not too different in this case, okay? I was looking for a possibility of being much different, all right? But let's see if I did this by accident, right? I used those limits as the average of my limit, lower of my class limits as to calculate the midpoints. And if I do the standard deviation here, rounding to one decimal place, 3.4, it still work. But I'm wondering if we didn't, if it would have been a problem, okay? Consecutive lower limits, let's see what that standard deviation looks like here. Oh, I forgot to put my bins. We're talking about temperature, frequency, computing, right? And again, because of that here, we can see the decimal. Remember our last result with the limits itself, the class limits, we had 3.43 something, right? Notice here, when I did consecutive lower limits, the correct way I should say, it still rounds to 3.4 because of that 5 outside, but you can imagine if we got something more kind of different, didn't round the same, we would have gotten that wrong, okay? All right, so watching out for that, just remember with that grouped bin data, when we have the mean or standard deviation from a frequency distribution table, keep track, okay, here's our classes, okay? Those bins are your classes. The counts are your frequencies, which are on that table. We're going to do midpoints, consecutive lower limits, and then we want to find the mean, standard deviation, and there's our values. Okay, and again, with our appropriate using the consecutive lower limits, we got that 3.35. All right, so there's that type of problem. Let me save that work, okay? And so then one last piece here, if we take a look in our assignment, let me shift this over. And jumping to our 5-number summary. Let's take a second here. Question number 2. Hopefully we can just jump right into our data. Oh, so this one's skewed. So in this case, looking at talking about skewed, right? The idea of a graph or a distribution being skewed is kind of counterintuitive in my opinion, right? When I say that it's skewed to the right, that means that we have the lower, we're stretching the graph there, or in this case, in terms of our box and whisker plot or a box plot, that we have the longer line on the appropriate side. So since we have a longer line, this stretch on the left side, I would say that this distribution is skewed to the left. We have that long, we're stretching out to meet all of our data out here. Symmetric, right, means that the box is in the middle, relatively equal length whiskers or lines outwards to the minimum and maximum, okay? And there we go, right? So because of the longer, that stretched out piece towards the left, right, is skewed to the left. Had it been a longer line on the right, a short line on the left side, we skewed to the right. Okay. And so now the 5-number summary. And so looking, we are going to have to kind of pick out those values, right? So the 5-number summary, minimum, first quartile, where this edge of the box starts. Median, not the mean, the median, that's this middle line. Third quartile, where that box ends, and the maximum, the biggest value, right? So off the bat, my minimum is 0, the maximum is 20. I can see that where the graph ends. So now, looking here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each mark counts as 1. So in this case, the first quartile, Q1, where that box starts on our graph, 9. The median, where our line is, kind of that middle, right? So the 5-number summary uses the quartile values, separating that data set into 4 equally sized groups. So 25% of the data is between 0 and 9. 25% of the data is between 9 and 1, 2, 3, 4, 5. Right, so it's 15 there. Make sure I count that right. So between 9 and 15, our median is 15. It ends Q3 right there. That box is at Q3, which is 19. And there's reading from that box plot. And likewise, vice versa, building that box plot, you find your 5-number summary first, and then map out those points. So let me go back, or let's go forward. Okay. I'm trying to find there's a place where we can calculate. Okay. I guess they don't necessarily have it. That's fine. All right. So let's see. Let's go back to question 1. All right. So let's go back. Actually, I'm going to sneak into StatCrunch. Let me save that. Not worried about there. We go back into our assignments. And I just borrow one of these data sets. I'll go back into homework 1 this time. Let's do question 3. Hopefully we get some data to work on. All right, I'm trying to find a bigger data set. Let's see here. Okay, we can do this one, that's fine. Okay, and so in this case, this following data represents the miles per gallon, the MPG, right? First model car and 6 randomly selected vehicles. Okay, so if I want to open the StatCrunch, we have our data, and we can expand data. We can have longer data sets to make it a little more interesting. Again, with these smaller values, not too great, but we have this data here. If I want to calculate, if I want to find that 5-number summary, again, we're going to go into that summary stats, right? Our data is in a column, variable 1, but now I'm not worried necessarily about the mean standard deviation. We can do so, but if I want to be particular about finding our 5-number summary, I can even go in order, minimum, and then now to highlight more than one, I hold the control key, or sometimes on Apple devices, it might be command, right? Q1. And then if I want to find the median next, you can go in any order you want to, truthfully, but I'll just kind of make it follow that five-number summary. Median, right? Holding down control, Q3, and then our maximum, right? So there's my five-number summary. Minimum, first quartile, Q1, median, third quartile, Q3, and max compute. And there we go. So it gives us our five-number summary. And so then when it comes to building that box plot, you draw your standard number line down below, right? Try to keep even with your spacing. You can count by 10, you can count by 5, whatever you need to do to really match your data. All right, we can go a single unit, count by ones, okay? Whatever's going to best diagram your data, but you want to keep it even. So use a standard, normal, I know we're going to use that wording later in chapter 7, but just a regular, evenly spaced number line down below. And then you're going to mark out our particular values. You're going to make a location for the minimum, a solid dot up above. Then you're going to start a line for the first quartile, and then you're going to connect your minimum to that first quartile, that box, the edge, the middle. Then for our boxes between Q1, median, Q3, right? So labeling those values, being careful with that spacing, and that's going to show you how congested or spread out the data is, okay? And then you're going to end at the max, right? And again, we'll draw a line from the Q3 box out to the maximum for that box plot, okay? All right, so there's some practice, I know, for our StatCrunch. Sorry for bouncing around in the homework problems, but hopefully you can see, again, it's not necessarily always quick and clean. Sometimes you have to play around with it a little bit to figure out, okay? And so one thing more I wanted to discuss, going back to our Canvas page, right? And again, we have Desmos on our Canvas page, the home page here. We have all of our information kind of organized. These will take you to the modules, those different notes, the written notes I have incorporating these, okay? Also down below, links that Desmos, the scientific calculator I was using. Likewise, StatCrunch will take you right there to it, okay? I know there's always a link within my lab, but during the exams and so on, just going to StatCrunch directly, you'll see. You can open StatCrunch, or you might need to log in and so on, but you can do that work, right? Desmos will take you to Desmos, the one I just showed you. But also up here, I mentioned it in one of my announcements, there's also reviews for the in-person exams, okay? So if I click on that link, it's at the bottom of the module, right? So it's on the modules page. Up above are all those notes I had provided for you all. But here's a review. Here's a blank for exam number 1, the exam coming up. Okay, it's called 16. That's just our old numbering system for our statistics courses. But you'll see kind of some of the types of problems that you're going to have to work by hand, right? Or using StatCrunch as well. I honestly don't use StatCrunch for chapter 2 work, the graphing or organizing, okay? I use StatCrunch mainly for chapter 3 work, okay? But working on those, I'm going to scroll through kind of quickly. It gives you an idea. Right now we're calculating the mean, and just keep careful here. Now I'm talking about a population in this group, not a sample. So remember, when it comes to standard deviation, that sigma, that symbol, that Greek symbol, we're going to use the unadjusted standard deviation in StatCrunch, okay? And then range, standard deviation, all these values, truthfully, we can find in StatCrunch, okay? And then now kind of making a comparison, looking at some more data right now, a five-number summary, so on, okay? And then in addition to having that review, there's also solutions for it, okay? So I did try to do my best to show you the solutions, how I present it. It might be a little bit differently formatted because I'm going to ask you for like that unrounded value. So I'm going to ask you for this specifically just so I can see it. Again, with some of this work, if there might not be a formula that we're using, or there's a formula we're using, but maybe we're not doing it by hand. So just let me know. Okay, on StatCrunch, there's my unrounded value. There's my rounded value. Okay, standard deviation, same idea. On StatCrunch, so just let me know how you're getting that value. If I just see this result, I don't know how you got there. It's going to be hard for me to give partial credit or even credit for that problem because I want to understand how you're getting those results. Okay, and again, a lot of this work we can do with StatCrunch, but I do provide formulas. These are ones that are provided by the textbook publisher, so it's kind of clean, organized. All right, chapter 2, relative frequency, class midpoints is kind of talking about how that calculation goes. Then those longer formulas. You can use these if you want to, but like I mentioned, if you're doing StatCrunch, just let me know it's StatCrunch. and then your long unrounded value, then your rounded value, and we're good, okay? And so for each of our exams, I have these sets of reviews as well as formula sheets that I'm going to provide just so you understand, you'll see what's going to be there, okay? All right, so hopefully that's going to be a good tool, a good assistance in helping you get prepared for our exam. And also, more importantly, I know there's always a question about how do I use StatCrunch. And so as we start to go forward, in chapter 7, we really use the StatCrunch again. Chapter 5 is probabilities, so not so much there, okay? That's more of scientific calculator work. But I'll make another video at that time, a little bit closer, so you have some opportunity to practice, okay? All right, y'all, so there we go. If you have any questions, definitely never hesitate to ask, email me, visit me office hours, either online, in person, whatever it is. Never hesitate to ask questions with a Canvas inbox or my email address, okay? All right, y'all, take care, be safe, and definitely happy doing statistics. All right.